There is a number that astronomers rarely say out loud, because once you understand what it means, it changes the shape of the sky above you. The number is 46.5 billion. That is not the age of the universe. The universe is younger than that. The universe is roughly 14.8 billion years old, give or take a small correction that cosmologists argue about politely in journals. 46.5 billion is something else. It is the distance, measured in light years, to the farthest edge of everything we can in principle ever see. It is the radius of what astronomers call the observable universe. And it is larger than the age of the universe multiplied by the speed of light, which sounds, at first, like a contradiction. It is not a contradiction, it is a consequence. The space between us and the most distant light has been stretching the entire time that light has been traveling. The photon did not cheat. The ruler grew underneath it. That fact quietly is where this script begins. Not with rockets, not with warp drives, with a ruler that will not hold still. It is worth pausing on that image for a moment, because most of what will happen tonight rests on it. When we say space is expanding, we do not mean that galaxies are flying away from us the way debris flies from an explosion. We mean that the fabric between things is itself lengthening. Imagine a loaf of bread rising in an oven, and imagine raisins scattered through the dough. As the dough expands, every raisin moves away from every other raisin. Not because the raisins are moving, but because the dough between them is getting larger. No raisin is at the center. Every raisin, from its own point of view, sees all the others receding. There is no privileged location. There is no edge. There is only the dough, quietly growing in every direction at once. That is the universe. And we are, each of us, one of the raisins. Every galaxy we see, every distant cluster, every faint smudge of ancient light, they are not moving through space toward or away from us. They are being carried along by the slow unfolding of the space between us. Which means, if you let the thought settle, that there is no direction you could ever travel in which the universe would get simpler. You cannot go outward. There is no outward. Every direction is the middle. Because the question I want to sit with tonight, and it is a strange question, stranger than it sounds, is this. If a human being stepped into some perfect ship tomorrow, a ship with no fuel limits, no biological fragility, no engineering compromises, a ship that could do anything physics allows, how far could that person actually go before something, somewhere, stopped them? It is the kind of question that feels like it should have a simple answer. It does not. It has several answers, layered on top of one another like geological strata, and each one is a different kind of wall. Some of those walls are made of physics. Some are made of time. One of them, the last one, is not really a wall at all. It is the shape of the universe closing behind you as you move. I should probably introduce myself, or rather, let you forget I am here. My name is Elias. This channel, Space and Silence, exists for nights like this one, when sleep is slow to arrive and the mind wants something vast and quiet to rest against. If the voice finds you well tonight, you are welcome to stay. You are welcome to drift. There is a small button somewhere on your screen that lets the algorithm know you would like this voice to return, and I am grateful whenever someone presses it, but only if the voice has earned it. That is all I will say about that. So, 46.5 billion light years. Let us start much, much closer to home. The first wall, the one nearly everyone has heard of, sits 93 million miles away, or thereabouts, on the surface of the sun.
It is not really a wall for us. No human is going to the surface of the sun, but it is the first edge of a region we think of as home. Our solar system is a small gravitational pond, and the sun sits at the center of it, and everything that matters to human civilization, every piece of land that has ever grown wheat, every ocean that has ever held a tide, fits inside the thin skin of a single, small, rocky planet orbiting that star at a distance light crosses in about 8 minutes and 20 seconds. That is the first scale. 8 minutes of light. If you could travel at the speed of light, which you cannot, you could go from here to the sun during a single, reasonable pause in a conversation. The next scale out is a different creature. The farthest human-made object from Earth is a spacecraft named Voyager 1, launched in 1977, when the engineers who built it did not expect it to still be sending signals half a century later. It is still sending signals. Barely. Its plutonium power source is fading, and its transmitters are weakening, and within a few more years it will go silent, and then it will simply continue, cold and mute, into the dark. I think about Voyager sometimes, late at night, when the house is quiet. It is a small thing, a few 100 kilograms of metal and circuitry, built by hand in a clean room in California, with instruments that are primitive by modern standards. The computing power aboard is less than what is in the cheapest phone you could buy today. And yet it has crossed the heliopause, the boundary where the sun's wind thins into the wind of other stars, and it is the first object made by any human that has done so. It carries a gold record, pressed with sounds from Earth, whale songs, greetings in 55 languages, a heartbeat, the pages of a child reading. Chuck Berry. Nobody will ever hear it.
Not because the universe is cruel, but because the universe is large and Voyager is small. And the probability of that record being found by anything capable of playing it is vanishingly close to zero. The record will most likely drift, uncorrupted, for longer than the sun will shine. It will still be readable, in principle, when the Earth itself has been consumed. A cold metal disk in a cold metal spacecraft, carrying the memory of a species that by then will have been gone for billions of years. That thought, I think, contains almost everything tonight's script is about. We sent a small bottle into the largest ocean ever measured. We did it anyway. We knew the odds. And the reason we did it was not for the recipient. The reason we did it was for us. To say to ourselves that we had tried. That we were the kind of animal that, at least once, had aimed something at the stars and let it go. Voyager 1 is, at the time of this recording, somewhere around 165 astronomical units from the sun, where an astronomical unit is the distance from the Earth to the sun. It has been traveling for almost 5 decades. It has moved in that time about 1/1000th of a light year. 1/1000th of a light year in 50 years. At the fastest speed a human-made object has ever really sustained in deep space. Our nearest stellar neighbor, the triple star system called Alpha Centauri, is 4.25 light-years away. At Voyager speed, reaching it would take something close to 70,000 years. Not 70, 70,000. Longer than the entirety of modern human civilization. Longer than the span between the first cave paintings at Chauvet and the device you are listening on right now. If a Voyager speed ship had left Earth at the moment our species first started drawing on walls, it would still, tonight, be less than halfway to the nearest star. This is the first thing the universe does to a traveler. It does not stop you.
It simply waits. And already, quietly, the question begins to change shape. We asked how far a human could travel. But in space, distance and time
are the same substance seen from two different angles. You cannot ask how far without also asking how long, and you cannot ask how long without asking whose clock. Einstein knew this. He did not phrase it this way, but he knew it. The universe does not hand out a single shared timepiece. Every object that moves carries its own clock, and clocks that move quickly, relative to other clocks, tick slowly. This sounds like a parlor trick. It is not a parlor trick. It is measured every day in particle accelerators and in the tiny corrections that keep GPS satellites honest. Move fast enough, and time, for you, slows down. Which means there is a loophole, a strange, beautiful, cruel loophole. If a human being could climb into a ship that accelerates at one gravity, the same gentle downward pull you are feeling right now, pressing you into whatever surface you are resting on, and hold that acceleration steadily, the ship would approach the speed of light. It would never reach it. Nothing with mass can. But it would get close enough, within a few years of ship time, that the traveler's clock would begin to drift sharply away from the clocks left behind on Earth. Here is what that means concretely. A person in such a ship, accelerating at one gravity for roughly a year, and then turning the engines around and decelerating for another year, could reach the center of our galaxy, 26,000 light-years away, within a single human lifetime. Their lifetime, not Earth's. On Earth, 26,000 years would pass. Civilizations would rise and fall. Languages we speak tonight would be unreadable to anyone alive at the journey's end. But the traveler would step out of the ship, if they stepped out at all, only a few decades older than when they stepped in.
With enough runway, enough acceleration, the same traveler could cross the entire Milky Way galaxy, 100,000 light-years, in something like 40 years of their own time. They could reach the Andromeda galaxy, 2.5 million light-years distant, in roughly 60 years of subjective experience. Everything you have ever seen in a photograph from a telescope, in principle, reachable inside one life. This is where the script could become triumphant. This is where a different kind of channel would tell you that humanity is limitless, that the stars are ours for the taking. I will not tell you that, because the loophole, as I said, is also cruel. The traveler who reaches Andromeda returns, if they return at all, to an Earth where 5 million years have passed. Every person they ever knew is not only dead, but forgotten. The continents have moved. The species that sees their ship descend, if any species is there to see it, may not be human in any sense we would recognize. They have not traveled to Andromeda so much as they have traveled to a version of time in which Andromeda and their home are both equally strange. I want to sit with that for a moment, because it is, I think, one of the quieter cruelties of relativity, and it does not get said often enough. When we imagine a journey to another star, we imagine a traveler who leaves and returns. We imagine a homecoming. That is how every story of exploration works. Someone goes, someone sees, someone comes back and tells the rest of us what was found. The report is what makes the voyage meaningful to the community that sent it. But a relativistic journey does not permit a homecoming. The traveler can go, and the traveler can, with enough fuel, come back to the physical location that Earth once occupied. But that location, by the time they arrive, will not be the Earth they left. The ocean levels will have changed. The coastlines will have been redrawn. The species that was listening when they departed will have been succeeded by something else, or by nothing at all. The report they bring back cannot be delivered because the audience it was prepared for no longer exists. This is not a hypothetical tragedy. It is baked into the physics of the universe. The faster you travel, the more severe it becomes. It is not a flaw in our current engineering. It is not something a better ship could solve. It is the shape of space-time itself, and it says, gently but firmly, you may go or you may stay, but you may not do both. And this, I think, is the first real wall. Not a wall of distance, a wall of belonging. You can go anywhere, given the right engine, but you cannot go anywhere and also come home. Something to sit with, maybe, in the quiet. Let us keep moving outward, past the Milky Way, past our local group of galaxies, past the small cluster of dwarf galaxies that orbit us like moths around a porch light. The universe begins to thin. Galaxies gather into groups, groups into clusters, clusters into superclusters, and superclusters into the vast filamentary web that cosmologists call the large-scale structure. If you could pull back far enough, the universe would look less like a scatter of stars and more like the pale ghost of a neuron, or the veins inside a leaf held up to light. Threads of galaxies connecting knots of galaxies, with enormous empty regions between them called voids. The largest of these voids, the Boötes void, is roughly 330 million light-years across. It contains galaxies, but far fewer than it should. If you were to stand, somehow, at the center of the Boötes void and look up, the nearest galaxy would be so distant that for most of human history, we would not have been able to see it at all. And yet it is only one of thousands of such voids. They occupy most of the volume of the universe. The bright places, the galaxies, the clusters, the places where anything interesting is happening, are rare. They are, statistically, the exception. An astronomer named Robert Kirshner, along with two colleagues, first mapped the Boötes void in the early 1980s. They were not expecting to find an emptiness of that scale. No one had seen anything like it. When the result was published, there was a brief, serious debate about whether it could be real at all, whether the instruments had missed something, whether there was some hidden population of galaxies inside it that had not been counted. Further observation confirmed the emptiness. The void was simply, actually, there. What makes this strange is that the large-scale universe, at the time the cosmic microwave background was emitted, was almost perfectly smooth. The temperature variations in the background are tiny, about 1 part in 100,000. Those tiny variations were the seeds from which all the structure of the universe grew. Every galaxy, every cluster, every filament of the cosmic web began as a small density fluctuation in that almost uniform early plasma. Somehow, from those tiny seeds, over billions of years, the universe grew the enormous emptinesses and the enormous concentrations we see today. Gravity, patiently, pulling matter toward matter until the rich got richer and the empty got emptier, and the universe divided itself into cities and wilderness. We are, for what it is worth, in one of the cities. The Milky Way is part of the local group, which is part of the Virgo supercluster, which is part of a larger structure called the Laniakea supercluster, a name that means, in Hawaiian, immeasurable heaven. Laniakea contains something like 100,000 galaxies, bound together in a slow gravitational flow that cosmologists are only beginning to map. We are near its edge. Our galaxy is drifting, along with everything around it, toward a region called the Great Attractor, a dense concentration of mass in the direction of the constellation Centaurus. We have been drifting toward the Great Attractor for longer than the sun has existed. We will not, individually, live long enough to arrive. I find that comforting in a particular way, that our entire galaxy and our entire local cluster and our entire supercluster are falling toward something we cannot see, not falling dangerously, not falling in any sense that matters to a human life, but simply drifting, patiently, in a direction we did not choose. We did not ask to come this way. We are going anyway. The universe has a gentle current, and we are inside it, and we have always been. The universe is mostly empty, and I mean mostly in a way the word can barely carry. If the solar system were shrunk so that the sun was the size of a grain of sand, the nearest star would be another grain of sand, roughly 10 kilometers away. Now take that same scale, grain of sand, 10 kilometers, and expand it to cover the whole observable universe. You would need a volume of space comparable to the actual Earth itself, filled almost entirely with nothing, to hold even a small portion of what is really out there. Matter, in the cosmic sense, is vanishingly rare. We live inside an ocean of emptiness, occasionally interrupted by light. I find this comforting, though I understand not everyone does. There is a worldview in which the emptiness feels like abandonment. There is another worldview in which it feels like space, room to breathe, room to be small, room to exist without the universe watching. The indifference of the cosmos is not cruelty. It is simply the absence of surveillance. No one out there is grading us. No one is tallying our errors. The dark between the stars is not judgment. It is just dark. If you are awake tonight, and the hour is late, and the world feels heavy, that distinction may matter. Now, back to the question, how far can a traveler go? We have established that time is flexible, that a sufficiently fast ship could, in principle, cross galaxies within a single life. We have established that the universe is mostly empty, and that the bright places are far apart. What we have not yet established is that the emptiness, the space itself, is doing something. It is moving, not in the way a river moves. Rivers have banks. Space has no banks. Space is moving in the sense that the distance between any 2 points that are not gravitationally bound to each other is growing. This is the expansion of the universe, and it is one of the most thoroughly confirmed facts in all of modern cosmology. We have measured it in the light of distant supernovae. We have measured it in the cosmic microwave background, the faint leftover warmth of the Big Bang that fills every cubic centimeter of space. We have measured it in the way galaxies drift away from each other, and the pattern is consistent. The farther away a galaxy is, the faster it is receding from us, not because it is flying through space, because the space between us and it is getting longer. This was discovered in its early form by Edwin Hubble, working with older data and with help he did not always credit. The rate of this stretching is called the Hubble constant, and the exact value is one of the great unresolved arguments in modern astronomy. Different methods give slightly different numbers, and the disagreement refuses to go away. But the stretching itself is not in doubt. The universe is getting larger, every second, everywhere at once. And roughly 14 billion years ago, we discovered something worse, or more beautiful, depending on how you hold it. The stretching is accelerating. For most of the 20th century, astronomers assumed that the expansion of the universe was slowing down. Gravity, after all, should be pulling everything back toward everything else. A universe full of matter should be decelerating. When a team of astronomers in the late 1990s
tried to measure exactly how much that deceleration was slowing the cosmos. They found something none of them expected. The expansion was not slowing, it was speeding up. Something was pushing space apart, at every scale, faster and faster. And that something, we still do not know what it is called, for want of a better word, dark energy. The name is an admission of ignorance. It is what we call the thing we cannot see that appears to be doing most of the work. And here is why that matters for our traveler. If space is expanding and that expansion is accelerating, then there is a point, a distance, beyond which the space between us and a distant galaxy is growing faster than light can cross it. Light leaving that galaxy, aimed directly at us, will never arrive. The space it is swimming through is lengthening faster than it can advance. It will fall behind forever, like a swimmer in a river flowing backwards faster than they can stroke. This distance has a name. It is called the cosmological event horizon, and it is, in the truest and most final sense, a wall. It sits currently at about 16 billion light-years from us. Anything beyond that horizon, and most of the observable universe already is beyond it, is already lost. Not invisible, lost. No signal from there will ever reach us again. No ship from here, no matter how fast, can ever reach there. The light we see from those distant galaxies tonight is ancient light. Light from an era when the expansion had not yet carried them out of reach. Their current selves, whatever they look like now, are on the other side of a door that closed without closing. I want to let that settle for a moment. Not with drama, just quietly. The universe we can see is not the universe we can touch.
Most of what we can see is already gone.
This is where, I think, it is useful to pause. Because the next part of this story, what happens to the traveler who tries to outrun that horizon? What the universe looks like 100 billion years from now, what the final shape of everything might be, requires a slower breath. It requires the hour to be later, the lights to be dimmer, and the mind to be willing to hold something that does not resolve. We will get there. For now, it is enough to notice what has already happened in the last few minutes. We asked a simple question. How far could a human travel? We began with the sun, 8 minutes of light away, and we found Voyager, drifting for half a century to cover 1,000th of a light-year. We found the loophole of relativistic time, which lets a single life reach across galaxies. We found the cruelty of that loophole, which severs the traveler from home. We found the emptiness between the bright places, and the argument that such emptiness is not hostile, but simply neutral. And finally, just now, we found the first true wall. A wall made not of matter or distance, but of the expansion of space itself. And we have not yet asked the hardest questions. We have not yet asked what happens to the traveler who decides, knowing all of this, to go anyway. We have not yet asked what the sky looks like from the inside of a long, long journey. We have not yet asked whether anything, any information, any photon, any echo, ever really escapes the place where it is born. I will ask those questions shortly, but the hour is what it is, and some thoughts are better held than hurried. If you are awake, and the room is dark, and the world outside is quiet, consider this. Somewhere, right now, there is a galaxy whose light left it 12 billion years ago to come find us. That light has been traveling, unchanged, through cold, empty space for longer than the Earth has existed. It will arrive here, some of it, tonight.
A few of its photons will strike the mirror of a telescope in Chile, or in Hawaii, or in orbit above us and be recorded. The rest will pass through the Earth without being noticed and continue on into the dark on the other side. That light has been coming toward us the entire time our species has existed, the entire time our ancestors were anything, the entire time the continents were shaped the way they are shaped now. And we, tonight, are the only ones who will ever see it. So let us say the traveler goes anyway. Let us say she, or he, or they, the pronouns do not much matter when the journey is this long, climbs into the ship knowing everything we have said so far, knowing that Earth will age past them, knowing that home, in any meaningful sense, will dissolve behind them, knowing that most of the universe they can see is already beyond their reach, and knowing, finally, that the horizon they are chasing is not holding still. They go anyway. People do. For the purposes of tonight's thought, let us give them the most generous ship physics will allow. A ship that accelerates at one gravity indefinitely. No fuel constraints, no hull failures, no biological cost. A clean idealization. The kind of ship engineers do not build, but physicists use as a ruler. For the first year of ship time, they feel heavy. They feel, in fact, exactly as heavy as they did on Earth, because one gravity of thrust pressing them against the floor of the cabin is indistinguishable from inside from standing on a planet. This is Einstein's equivalence principle, and it means something quietly strange. The traveler cannot tell, by any experiment conducted inside the ship, whether they are accelerating through the void or simply resting on a stationary world. The universe, from their point of view, may as well be still. The ship is the room. The room has a floor. That is all. Outside the window, however, the view is changing. At first, slowly. The stars drift. The constellations deform. Familiar patterns. The shape you would pick out of a northern sky on a cold, clear night, begin to tilt and stretch. By the end of the first ship year, the traveler is moving at roughly 77% of the speed of light, and strange things begin to happen to light itself. Stars directly ahead of the ship compress into a tight, bright cluster, crowded into a smaller and smaller cone at the bow. Their light is blue-shifted, pushed up the spectrum toward shorter wavelengths, so that what would have been red stars become yellow, yellow become white, white become blue, and blue become ultraviolet and pass out of sight entirely. Behind the ship, the sky goes dark and red. Starlight there is stretched, red-shifted, dimmed, until eventually, if the ship goes fast enough, most of the visible universe behind them simply fades out of the visible spectrum altogether. The cosmos through the bow window becomes a crown of white-hot light in a narrow ring, surrounded on all sides by a deepening black. This effect is called relativistic beaming, and it is real. It is what the universe actually looks like from inside a sufficiently fast ship. Not the star streaks of science fiction. A tightening halo of light at the front, darkness everywhere else. I want to hold on this image for a moment, because I think it is one of the more honest pictures we have of what long travel actually becomes. You do not fly through a universe. The universe narrows. The stars ahead of you crowd into a small, bright eye, and everything else closes like a shutter. The traveler is not in open space anymore. They are inside a thin tunnel of light, and the tunnel is of their own making. By the end of the second ship year, they have passed Alpha Centauri. By the end of the fourth, they are beyond the nearest 100 stars. By the end of the 10th, they are crossing into regions of the galactic disk that no probe from Earth will ever reach on its own. The galaxy, for them, is becoming a small thing.
And here, I think, is where the script should slow. Because the hour is what it is, and the rest of what I want to tell you is less about arithmetic and more about how a thing feels when you look at it from the right distance. The galaxy, seen from outside, from a vantage point a few tens of thousands of light years above its plane, is not what photographs suggest. Photographs are made of long exposures, of stacked images, of coaxed and filtered light. What you would see, with a human eye from that distance, is something more like a faint, pale mist arranged in a slow spiral, with a brighter core at the center, like an ember under ash. It would not blaze, it would glow. The way a city glows when seen from a plane at night, if the plane were absurdly high and the city absurdly quiet. 200 billion stars, give or take. 100 billion planets, possibly more. Some of them almost certainly holding water. Some of them almost certainly holding the conditions in which chemistry becomes biology. And almost none of them, statistically, holding anything that knows it is looking back. We do not know that last part for certain. That is the careful thing to say. We have not yet found, in any confirmed way, any sign of a second civilization. We have searched, with the radio telescopes we have, for only a short time, in only a narrow slice of frequencies, at only a small set of targets. The silence we have observed may be a real silence. It may be a silence that just means we have not been listening long enough or widely enough. The question remains open. The honest answer, tonight, is that we do not know whether we are alone in the galaxy, and the instruments required to settle the question do not yet exist. But the silence, so far, is striking, and it has a name. Enrico Fermi, over a long lunch, is said to have asked a simple question about extraterrestrial civilizations.
Where are they? If life is common, if technology is common, if even a small fraction of stars host species that build radios and ships, the galaxy should, by simple arithmetic, be loud. It should be full of evidence, old probes, old signals, old structures. And yet the sky, at the frequencies we have listened to, is mostly empty of anything we can identify as artificial. There are many possible explanations, and I will not choose among them, because choosing would be dishonest. Perhaps life is rare. Perhaps technology is rare. Perhaps civilizations are brief. They rise, they burn their atmospheres, they fall silent before anyone hears them. Perhaps they are careful and hide. Perhaps we are too early or too late, or looking in the wrong way. Perhaps, and I say this without weight, they are here but do not speak to us. I want to spend a minute on that last one, not because I believe it particularly, and not because I disbelieve it, but because it raises a question that is worth holding, which is the question of what a signal even is. A signal is a pattern that carries intent, or at least a pattern that could only have come from structure. When we listen to the sky, what we are listening for, really, is a pattern that does not belong there. A beep that repeats too evenly. A line in a spectrum that has no natural explanation. A narrow slice of radio that should, by physics alone, be empty and is not. This is a hard thing to listen for. The universe is noisy in its own way. Pulsars tick like clocks. Quasars flicker. The plasma of our own galaxy hums with random electromagnetic weather. Against that background, a deliberate signal would have to be loud enough, or strange enough, or persistent enough that we could rule out every natural explanation. And we would have to be listening at the right moment, in the right direction, at the right frequency. The chances of catching a signal, even if signals are sent, are not large. There is an old phrase, attributed to various people. The absence of evidence is not the evidence of absence. It applies here.
We have heard nothing so far that we could not explain. That is not the same as hearing silence. That is only the same as not having looked long enough. And in the meantime, our own planet has been leaking radio into space for about a century. A thin shell of old broadcasts, the news, the music, the first television transmissions, is expanding outward from the Earth at the speed of light. That shell is, right now, only about 100 light-years across. In the context of the galaxy, it is a microscopic bubble, a sphere of our own noise drifting through a mostly silent sea, already thin and weak by the time it reaches the nearest stars. If there is anyone out there listening for us, the same way we listen for them, they would have to be very close and very patient and very lucky to catch us at all. The point for our traveler is this. Even in a galaxy of 200 billion stars, the probability of accidentally encountering another mind is effectively 0. The distances are too great. The timelines do not overlap. Civilizations, if they exist, are likely separated by thousands or millions of years, and thousands or millions of light years. And the overlap of any two of them in the same place at the same moment is so small that one might cross the entire Milky Way at relativistic speed without passing near a living thing except what they brought with them. This is, I think, the second wall. Not a wall of physics, a wall of company. You can go anywhere, but when you arrive, there will be no one there to notice that you came. The ship continues. By the end of the 20th ship year, the traveler has crossed the Milky Way entirely. They are in the intergalactic dark between our galaxy and its neighbors. There are no stars near them now, not in any sense a human eye would recognize.
The nearest star is tens of thousands of light years behind them, and the nearest galaxy, a satellite of ours called the Large Magellanic Cloud, is still 160,000 light years ahead. The ship is, for the first time, truly between. Outside the window, there is almost nothing. Occasionally, a rogue star, ejected from some galaxy long ago, drifts past in the middle distance. Occasionally, a dim cloud of hydrogen, too diffuse to have ever formed stars, registers on the instruments. Otherwise, it is dark. The crown of light at the bow still shines, tighter now than before, because the ship is faster. But the dark around it is no longer scattered with the faint glow of nearby stars. It is a solid, unrelieved black. I want to stay with that image for a moment. The ship between galaxies. Because it is, I think, the single most honest picture of where we actually live. Once you subtract the familiar props. We live, most of us, in places where the sky is lit. Street lamps, houses, cities, whole continents glowing at night. When we look up, even in the darkest places most of us can reach, the sky is still crowded. Our nearby stars are close enough that they dominate our perception of what space is. We imagine the universe as a field of stars because that is what we see. But that is a local illusion. That is what the inside of a galaxy looks like, from the perspective of a planet tangled up in it. The real universe, the one the ship is passing through now, is different. The real universe is almost entirely dark. A human standing on the outer hull of the traveler's ship, here in the intergalactic medium, would see almost nothing overhead. A faint blur, the Milky Way receding. Another faint blur, the Large Magellanic Cloud approaching. And between them, in every direction, darkness. Not the darkness of a bedroom with the lights off. Not the darkness of a forest at midnight. A darkness with no small lights in it. A darkness that the human eye
has no evolutionary preparation for. This is the universe we are actually inside of, the place we know, the luminous place, the place where stars are visible at a glance, is a thin, bright seam in a mostly dark fabric. If you could somehow step outside of every galaxy at once and see the universe from a sufficient distance, the galaxies would not look like scattered dots. They would look like a faint, thin froth, suspended in an enormous volume of emptiness. Most of everything is the emptiness. The traveler, if they are patient, watches. Space, even here, is not empty. It is more empty than language can easily carry, but it is not nothing. There are photons from the cosmic microwave background passing through the ship constantly, very cold, very faint, but present. There are stray particles, 1 per cubic meter or fewer, depending on the region. There are neutrinos from ancient supernovae, passing through the ship and through the traveler's body without interacting. A human body standing in intergalactic space is being pierced by uncountable particles every second, none of which register as anything at all. The dark is busy. It is just quiet. Let me linger on the cosmic microwave background for a moment, because it is, I think, the most underappreciated feature of the universe we inhabit, and it is present in the cabin whether the traveler notices or not. The cosmic microwave background is light, very old light. It was emitted roughly 380,000 years after the Big Bang, at the moment when the young universe had cooled enough for atoms to form for the first time. Before that, the cosmos was an opaque plasma, too hot and too dense for light to travel freely. Any photon that tried to cross any distance was scattered almost immediately.
Then, suddenly, across the whole volume of the cosmos at once, the temperature dropped below a certain threshold. Electrons and protons combined into neutral hydrogen, and the universe became transparent. The light that had been trapped inside the plasma was released, all at once, everywhere. And it has been traveling ever since. That light is still traveling. It fills every cubic centimeter of space. It is passing through you right now. It is passing through the walls of your room, through the ceiling, through the atmosphere above you, through the empty dark beyond. When you stand outside on a cold night, a small but non-zero portion of the chill you feel on your skin is not the night air. It is photons from the early universe arriving at your face after a journey of nearly 14 billion years. When old televisions, the analog kind, used to produce that hissing gray static between channels, a small fraction of that static was the cosmic microwave background. We grew up watching, without knowing it, the after-image of the Big Bang. Today the background has been redshifted by expansion to a temperature of about 2.7 degrees above absolute zero. It is cold, but it is there. Every direction you could ever point a sensitive enough instrument, the background is there, shining faintly, filling the sky like a kind of universal lamp that never quite goes out. It is the most uniform thing in the cosmos. It is everywhere, and it has been everywhere in some form since before the first star. The traveler in her ship is bathed in this light at all times. She cannot see it with her eyes. It is too cold for that. But her hull is always a tiny bit warmer than it would be in a truly empty universe, because the cosmic background is always depositing a little energy into it. The universe is keeping her, in a small way, less cold than it otherwise would be. A breath of warmth from the first moments, distributed evenly across 14 billion years of space,
Still reaching her cabin. I find that, for some reason, one of the kindest facts I know about the universe. No matter where the ship goes, no matter how deep into the intergalactic dark, how far from any star, how far from home, the warmth of the first fire is still arriving. Not bright, not strong, but present. The universe, at its very beginning, put out a light that was so diffuse and so widely cast that it would still be touching everything forever, or for as close to forever as anything in physics gets. There is another thing I want to mention here, because the ship is passing through it without seeing it, and it deserves to be named. Most of the matter in the universe is not made of atoms. It is made of something else. Something that does not emit light, does not absorb light, does not interact with ordinary matter except through gravity. We call it dark matter. We do not know what it is. We have looked for it with increasingly sensitive detectors for decades. We have not found it, but we can see what it does. We can see galaxies rotating faster than the visible matter inside them should allow. We can see clusters of galaxies held together by gravity far stronger than the gravity of their stars. We can see the way distant light is bent around invisible masses, as if there were enormous dark shapes in the sky, shapes we can only detect because they warp the light passing behind them. Dark matter is probably about 5 times more abundant than the matter we can see. The stars, the planets, the galaxies, the dust, the gas, every atom that has ever been part of anything visible, all of that together is a minority. Most of the universe is something else, and the something else is all around us, passing through the earth constantly, passing through our bodies, passing through the ship of our traveler.
We have been sitting in it our entire lives, and we have no idea what it is. I bring this up not to unsettle anyone. I bring it up because I think it belongs in a script about how far a human can travel. The honest answer, at a deep level, is that we are already traveling through something we do not understand. We do not need a ship for this. The unknown is already passing through the room. And somewhere in these ship years, I think, something happens to the traveler that is worth naming. I do not know what to call it exactly, except perhaps a kind of ordinary reverence. It is the thing that happens when you look at a vast, slow fact for long enough that your own proportions begin to adjust. The first time one sees the Milky Way from a truly dark sky, from a desert or a small island, or a mountain far from any town, there is a brief shock. The galaxy is visible, edge-on, as a soft band of light across the sky, and it looks like something that should not be allowed to be visible. It is too much. One takes a breath, and then, slowly, one's eyes adjust. The brightness is no longer shocking. It is simply the sky. The thing that was astounding becomes the thing that is there. This happens at every scale, I think, for anyone who keeps looking long enough. The astounding settles into the ordinary, not because the astonishment was false, but because the mind grows to hold it. And what the mind gains in that growth is a quieter kind of awe, one that does not require breathlessness, one that can coexist with sleep. If you are listening tonight, and the day behind you was difficult, or the day ahead of you is uncertain, you have my permission to drift. None of this is a test. None of this is a lecture. The words will keep moving whether or not you are following them, and the galaxy will be the galaxy whether or not we understand it. Let your thoughts unspool. The ship continues. By the end of the 40th ship year, the traveler has crossed the local group of galaxies. They have passed the Milky Way, the Andromeda galaxy, the Triangulum, the several dozen smaller galaxies that travel with us in a gravitational flock. Ahead of them, they can see the nearest major galaxy cluster, the Virgo cluster, a tight congregation of more than 1,000 galaxies, about 65 million light-years from Earth. Behind them, in the dark window at the stern, the local group has become a single, soft smudge of light, with two bright knots in it, the Milky Way and Andromeda, which by this point in the deep future have begun, from a certain angle, to merge. That merger is not a detail I have invented. It is expected. Andromeda is currently approaching us at roughly 110 kilometers per second, and in something like 4 to 5 billion years, the two galaxies will collide. The collision will not look like the cartoons suggest. Galaxies are mostly empty space, and almost no individual stars will strike each other. The two galaxies will pass through one another, their gravitational fields stirring and rearranging their stars, and eventually they will settle together into a single, larger, smoother, elliptical galaxy. Some astronomers have begun calling this future object Milkomeda, half-jokingly. The name does not matter. What matters is that the place we think of as home, the spiral arm, the position relative to the galactic core, the familiar shape of the night sky, will not exist by then. The shape will have changed. The night sky of Earth, if Earth still has a sky, will be unrecognizable. 4 to 5 billion years is also roughly how long the Sun has left. Not as a star exactly, but as the star we know. In about 5 billion years, the Sun will expand into a red giant. It will swallow Mercury. It will probably swallow Venus. The Earth may survive physically, barely, as a charred cinder, or it may be consumed. Either way, any meaningful version of the planet we live on tonight will be gone. Not in an explosion, in a slow puffing up as the Sun's outer layers bloat and shed themselves into space until what is left at the center is a white dwarf, a small, dense, slowly cooling ember the size of Earth, surrounded by a beautiful shell of glowing gas that will itself fade over tens of thousands of years. This is the ordinary fate of a star like ours. It is not cosmic tragedy. It is the middle of a life cycle that repeats, with variations, across the galaxy, over and over, for as long as the universe has existed. I mention this not to be grim. I mention it because, in the timescales we are now discussing, the difference between 5 billion years and 10 billion years and 100 billion years begins to lose its weight. At these scales, human timescales dissolve. A human life is roughly 80 years. Civilizations, when they last perhaps a few thousand. Species, a few million. The Sun will live for another 5 billion. The Milky Way, in some form, will persist for hundreds of billions. And the universe itself, the universe as a place where stars are possible, will continue for something like 100 trillion more years before the last stars burn out. 100 trillion. Not a number one can really hold, but one can set it down gently and look at it. And now, finally, we can return to the question the traveler carried with them from the start. How far can they go before the universe stops them? We have found, along the way, a series of walls that are not quite walls. The wall of Voyager's slowness, which is not a wall at all,
merely a reminder that chemical rockets are tiny things. The wall of relativistic time, which is really a door. You can pass through it, but what you pass through is the belonging you had. The wall of empty space, which is not a wall, but a reminder that arrival, in a meaningful sense, is hard. The wall of silence, the absence of other minds to welcome you on the far side. And then, past all of those, the wall that does not yield.
The cosmological event horizon.
The traveler, at 99.9% of the speed of light, approaches this horizon and finds that it retreats from them. They cannot gain on it, no matter how long the ship runs its engines, no matter how much subjective time passes for the crew. The horizon moves away at least as fast as the ship advances. It is a boundary of the universe they can in principle ever reach, and that boundary is shrinking in absolute terms while their ship is still moving outward. They are chasing something that is pulling away faster than they can run. And here is the coldest fact in cosmology, and I will say it gently. Every year that passes, more of the universe falls out of our reach. Every year, galaxies that were, in some long ago epoch, reachable in principle, galaxies whose light we could still have chased, cross the event horizon and become for us forever unreachable. The reachable volume of the universe is not stable. It is shrinking, not in the sense that things are moving closer, in the sense that the door is closing. If the current estimates of dark energy hold, and they may not, but if they do, then in roughly 150 billion years, every galaxy not gravitationally bound to us will have crossed our horizon. The Virgo cluster will be gone. Every distant spiral, every quasar, every evidence in the sky that the universe is anything more than a single, isolated island of stars, floating alone in a dark that has no other shore. The inhabitants of that far future universe, if there are any, will look up into a sky that contains only their own galaxy and the merged remnants of its nearest companions. They will not see the cosmic microwave background. They will not see distant galaxies. They will have no evidence, none, that the universe was ever larger than what they can see. They will not be able to rediscover the Big Bang. They will not be able to measure the expansion.
The universe will have become for them a small thing, and they will have no way of knowing that it was ever anything else. I find that somehow, one of the loneliest facts I know, not because it happens, because we are not the ones it happens to. We, tonight, are living at what may be the richest possible moment for seeing the universe. Old enough that galaxies have formed, young enough that most of them are still in view. The deep sky, the cosmic web, the primordial light, all of it is still available to the instruments we have. It will not always be. Which brings me to the last thing I want to say in this part of the script, before we reach the final stretch. The traveler, in our thought experiment, has not stopped. They are still accelerating. They will approach, arbitrarily closely, the speed of light, but never touch it. Their ship time will continue to tick. Years will pass for them, decades, perhaps centuries, depending on how long we imagine them alive. And no matter how long they travel, no matter how much of their own time they spend, they will never cross the horizon. They will only ever approach it asymptotically. The universe they wanted to reach has been slipping away from them since the first moment they lit the engines. They are not being punished. The universe is not unkind. It is simply shaped a particular way, and the shape of it is not designed for their arrival. It was not designed at all. It simply is what it is. This is the hardest thing to sit with, I think, and I want to leave it here for now,
without trying to resolve it tonight. We are in a universe where the reachable has a shape. The shape is closing. Every moment that passes, something, somewhere, slips past the edge of what a ship from Earth could in principle ever touch. And no one, on any ship, from any world, can stop that. Not the traveler, not the engineers who send them, not us, lying in our beds, listening to a voice describe a thing that is far away and getting farther.
It is not a cruelty. It is a geometry. And if you are still awake, if the voice is still with you, I would ask you to remember something small. The reachable has always had a shape, for us. Our arms reach only so far. Our voices carry only so far. Our lives stretch only so long. The universe is simply a larger instance of a constraint we have lived with since we were first children, reaching for things just out of grasp. The child learns, eventually, that not everything can be held. The species, in its long, slow way, is learning the same lesson at a different scale. Perhaps, in that lesson, there is even something close to peace. We will come back to the traveler once more in the last part of this script. We will follow them a little further into regions of time where stars themselves have mostly gone out, and see what, if anything, remains. We will ask what the universe becomes when it runs out of things to burn. And we will try, gently, to find a place to rest at the end of the thought. Not an answer exactly, but a place where the question no longer hurts. For now, the ship is still moving. The crown of light at the bow still shines. The traveler in her cabin is asleep. Somewhere, very far away, a window is lit. Someone is still up, reading. The light in that window will go out eventually. All lights do. But not yet. Not tonight. Let us go forward in time. Not with the ship now. Let us leave the traveler alone for a little while, asleep in her cabin, the crown of light still shining at the bow, still chasing a horizon she cannot catch. And let us pull back, farther than we have pulled back yet, and watch what the universe does when the night fully arrives. Because the universe, it turns out, has a night. Right now we live in an age of stars. The sky, in the parts of it that are dark enough, is filled with them. The galaxies we see through telescopes glow because stars are burning inside them, hydrogen fusing into helium, helium into carbon and oxygen, and the heavier things that eventually become planets, and, eventually, us. Starlight is the reason we can see at all, the reason photosynthesis happens, the reason the Earth is warm enough to hold water in the form that makes life possible. We are, ourselves, rearrangements of starlight. Every atom in your body, heavier than hydrogen, was forged in a star and scattered when that star died. The calcium in your bones, the iron in your blood, the oxygen you are breathing as you listen to this, all of it was stellar once. All of it passed through fire. And yet this age of stars, the age we are living in, the age we think of as simply the way things are, is not permanent. It is, in fact, rather brief on cosmic terms. The universe is about 14 billion years old. Stars will keep forming and burning for something like another 100 trillion years. After that, the gas needed to make new stars will be exhausted. The last stars will flicker and die, and the sky, everywhere, will go dark. 100 trillion years. Try to hold that number for a moment. The universe, so far, has existed for 14 billion. 100 trillion is roughly 7,000 times longer than all the time that has elapsed since the Big Bang. And we are at the very beginning of it. This is the strange thing about where we are in cosmic history. We think of our moment as late.
We look at the universe, and we see 14 billion years of buildup, and we assume that most of the story has happened. It has not. The story, if one measures it by duration, has barely started. We are embers from the opening fire. The long, slow cooling is still ahead. What happens in that cooling? Roughly this, if our current physics holds.
Within the next few 100 billion years, the smaller stars, the red dwarfs, which burn slowly and patiently and live the longest of any star, will still be shining. Red dwarfs can live for trillions of years. They burn cool and dim, so cool and dim that most of them are invisible to the naked eye, even when they are relatively nearby. But they are patient. They outlast the bright, loud stars like the sun by factors of thousands. And in the far future of the universe, after the suns are gone, the red dwarfs will be the last candles. Eventually, though, even the red dwarfs run out. Over the span of about 100 trillion years, the universe will exhaust its supply of fresh hydrogen, and no new stars will form. The last red dwarfs will fade into dim, cool remnants called white dwarfs, small Earth-sized objects that no longer fuse anything, but simply radiate away the heat they had. White dwarfs cool slowly. They cool over such long stretches of time that the word slowly loses its meaning. A white dwarf will take something like 1,000 trillion years to cool to the temperature of its surroundings. By then, the universe itself will be so cold, so diffuse, so far beyond anything we can currently imagine, that the word temperature itself begins to wobble. There is something, actually, that happens inside cooling white dwarfs that is worth naming, because it is quietly one of the strangest facts in astronomy. As they cool, the carbon and oxygen at their cores begin to crystallize. Not in any small way. The interior of an old white dwarf becomes, over billions of years, a single enormous crystal, a kind of diamond the mass of a star, hundreds of kilometers across, denser than anything on Earth, lit from within by the slow release of its own lingering heat. Our galaxy already contains such objects. There is one, about 50 light-years from Earth, that astronomers have measured directly, and whose core is believed to be largely crystallized already. It has been given a name because humans cannot resist naming things. But the name is less interesting than the object. A cold star, a dark gem the size of a world, drifting through the galaxy, unnoticed by anyone except the instruments that found it. I like the image of that, not because it is beautiful in a sentimental way, though it is, but because it is an image of what persists. When everything else goes quiet, the universe will still contain these crystallized ghosts of stars, scattered through the dark, each one a monument to a fire that was. They will not glow. They will not speak. They will simply be there, slowly, patiently, releasing the last of their old heat into a universe that has mostly stopped paying attention. The universe, at that point, will have entered what astronomers sometimes call the degenerate era. The stars will be gone. The galaxies will still exist, but they will have become dark. They will still rotate. They will still contain the corpses of stars, white dwarfs, neutron stars, black holes, but they will emit no visible light. A galaxy, in this era, is a wheel of invisible remnants, turning in a sky that has gone completely dark. Any observer within such a galaxy, if one could exist, would see no stars overhead. Only, perhaps, the faint glow of accretion onto nearby compact objects. Only the occasional flare when two dead things collide. And still, this is not the end. This is, in fact, still early. After the degenerate era comes the black hole era. Over the course of something like 10 to the 35th years, a number I will not try to pronounce in any meaningful way,
because the human mouth is not built to carry it. The protons that make up ordinary matter may decay. We are not certain of this. Proton decay has never been observed, but in many physics models, it is expected to happen given enough time. The neutron stars will evaporate. The white dwarfs will dissolve. Ordinary matter, as we know it, will cease to be a thing that exists. What will remain in the universe will be the black holes. That sentence I just said, ordinary matter will cease to be a thing that exists, deserves to be looked at once, carefully, before we move on. Because it describes a thing that has never happened in the history of anything, and it describes it almost casually, and I think the casualness hides what is actually being claimed. Every atom in your body has existed, in some form, for billions of years. The hydrogen in your blood is, in many cases, older than the Earth. It was present in the cloud of gas that collapsed to form the sun. Before that, it was drifting in interstellar space for billions of years. Before that, it was forged in the first few minutes after the Big Bang, in a brief window when the universe was hot enough and dense enough for atomic nuclei to form. The atoms in you are, in the most literal sense, among the oldest objects in the cosmos. They have outlasted galaxies. They have outlasted stars. They will, in all likelihood, still exist when the sun is a white dwarf and the Earth is gone. But not forever. If the proton decays, and this is a big if, an honest if, because we do not know, then even these ancient objects have a deadline, an enormous one, uncountable, but a deadline nonetheless. Over stretches of time so long that no analogy helps, the protons that have carried the story of matter since the first moments of the universe will quietly fall apart. The atoms will unravel. The last physical objects in the universe, the last things that could be called solid, will dissolve into lighter particles that cannot assemble into anything new. And what remains, as I said, will be the black holes, which have their own deadline. The black holes themselves are not eternal. Stephen Hawking showed decades ago that black holes radiate, very slowly, very faintly, but they radiate.
Over unimaginable spans of time, they lose mass through what is now called Hawking radiation, until finally they evaporate entirely. A black hole the mass of the sun will take about 10 to the 67th years to evaporate. A supermassive black hole at the center of a galaxy will take 10 to the 100th years, a 1 followed by 100 zeros. These numbers are so large that they no longer describe any duration a human can relate to. They are simply symbols, but they are also, according to our best physics, real. There is a kind of poetry in how a black hole ends, if you will let me linger on it. For most of its existence, it does almost nothing. It sits there, in the dark, emitting a radiation so faint that it is lost against the warmth of the cosmic microwave background. It cannot shrink while the background is warmer than its own radiation. It actually absorbs more than it emits. But eventually, as the universe expands and cools, the background drops below the black hole's temperature, and the balance reverses. Slowly, then faster, then suddenly, the black hole begins to radiate more than it absorbs. It shrinks. As it shrinks, it radiates hotter. As it radiates hotter, it shrinks faster. This goes on for ages beyond imagining, almost imperceptibly. And then, at the very end, in the last fraction of a second of a process that has taken longer than the age of the universe squared, the black hole flares up, brilliantly, briefly, and disappears. A final burst of radiation, released into the dark, and then nothing where it was.
A supermassive black hole ending is a flash of light at the end of a story so long that no one present could have witnessed the beginning. It is the last act of matter performed to an empty theater. And then, after all of that, the universe enters what is sometimes called the dark era. No stars, no planets, no atoms, no black holes.
Only a thin, cold bath of photons and leptons, spread across a volume of space so vast and so empty that the particles almost never encounter one another. Events in that era happen with almost unthinkable rarity. The universe becomes, in effect, a perfect silence. I want to say gently that this is not a horror. It sounds like one. It sounds like the end of everything, and in a certain sense, it is. But notice what is missing from the description. There is no suffering in it. There is no loss in progress. There is no one weeping. By the time the dark era arrives, all of the things that could ever have mourned the universe are already gone, and they are gone without ever having known that the universe was ending, because from their own moments, the universe was simply the universe. They were not watching it die. They were living their lives. This is the part I find, strangely, the most consoling. The universe will not suffer its own ending. Nothing alive will experience the last moment. The last moment, whenever it is, will not feel like an ending to anything present at it. It will simply be another cold, quiet instant, identical to the cold, quiet instant before it. The vast, stretching silence of the far future is not grief. It is only the absence of anyone to grieve. And meanwhile, long before any of that, we have our lives. I said at the start of this that the universe was not hostile, only indifferent. I want to come back to that now, because I think it matters more at this point in the script than it did at the beginning. A hostile universe would be watching us. A hostile universe would care about our defeat. The universe we live in does neither. It does not wish us well. It does not wish us ill. It simply is, and we happen, briefly, inside it. That is not a cold fact. That is, if you let it be, a gentle one. No one is rooting against you tonight. No larger intelligence is marking your errors. The wind outside your window. The gravity pulling you into your mattress. The photons from distant galaxies passing through the walls of your room. None of them are aware of you. And in that unawareness, there is a strange kind of permission. You are not required to earn your place here. You are simply here. And the universe, which does not know you exist, is quietly making room for you anyway, by doing nothing to stop you. The traveler, in our thought, has been alive for this whole descent. Let us rejoin her, briefly, one more time. She is by now, subjectively, by the clock of her own body, in perhaps her 3rd or 4th century. The ship has been accelerating at one gravity for longer than any human life should allow. We will permit ourselves this fiction for a moment because it makes the point. Outside the window, the universe has changed shape. Galaxies that were, when she departed, bright smudges of light in every direction are now almost entirely behind her, red-shifted out of visibility. Ahead, the crown of blue-shifted light has grown thinner because there are fewer galaxies ahead of her to supply it. Stars, in the deep future she is traveling toward, have begun to grow rarer. She is moving through an epoch of the universe in which the fires are going out. She has not slowed down. She cannot without losing the time dilation that has carried her this far. If she were to turn around and return to Earth now,
Earth would not exist, not in any recognizable sense. The Earth she left behind is, at the external clock, many billions of years older. The sun has long since died. The place she departed from is not a place anymore. She is the only one of her time who is still alive. Think for a moment about what that actually means, not in the abstract, in the simple, concrete sense. There is no one she could call, even if the radios on her ship could reach back to Earth, which they cannot.
There is no language she could speak and be understood in, because every language she ever learned has been extinct for longer than any language has ever existed. Every song she remembers, every lullaby, every half-forgotten tune, every fragment of music that someone once played in a room she loved, exists only inside her. She is the sole surviving instance of the civilization that raised her. When she dies, which she will eventually, that civilization ends a second time, completely and without record. And yet, the ship continues. She does not stop it. She could, in principle. She could reverse thrust, coast, let the engines die, drift into whatever patch of space happens to be nearby. But she does not. I do not know why. I am inventing her after all, and she is not real. But I can imagine her well enough to guess at what keeps her going. I think it is something simple. I think she has not finished looking. There is a kind of person, you may have met them, you may be one of them, who will keep going for no other reason than that the looking is not done. They are not trying to arrive anywhere. They are not trying to prove anything. They simply cannot stop noticing the next thing, and then the next thing, and then the next thing. The universe, for them, is a sequence of further things to notice, and the sequence does not exhaust. It only goes on for as long as they do. She is, I think, that kind of person. She is still at the window. She is still watching the light. This is, I think, the final wall. Not the horizon. She cannot reach the horizon, and never could. But the wall that shuts behind her. She has traveled so far in her own time that every contemporary she ever had is gone. Not just gone, forgotten. The civilizations that might have remembered her are themselves ancient or extinct. The records, if any, have not survived. She is as alone as anyone in the history of consciousness has ever been. And yet, I do not think it is a tragedy. Not quite. And here is why.
Every night, on Earth before she left, she used to look up at the stars. That is how this started, presumably, with someone young in some small place looking up. The stars she saw then were already old. The light reaching her eye had left its source decades, or centuries, or thousands of years before she was born. The night sky of any planet is always a museum of light, a gallery of moments already past. The act of looking up has never been the act of seeing the present. It has always been the act of receiving the echoes of distant fires. She is still looking up. She is still receiving echoes. The specific echoes have changed. The specific sources are different. But the gesture, a conscious thing tilted toward the sky and paying attention, is the same gesture she made as a child in whatever small bedroom she grew up in. She is doing the thing that people have always done, for as long as there have been people, and she is doing it in a setting where no one has ever done it before. If there is a kind of nobility available to us as a species, I think it lives in that small, constant gesture. Not in building the ship, not in crossing galaxies, in looking up and paying attention and letting the vastness in. You can do that too tonight if you are still awake. You do not need a ship. You do not need to travel at any fraction of the speed of light. You do not even need to leave your bed. You can close your eyes and imagine the sky above your ceiling and know with full certainty that out there, right now, photons that have been traveling for billions of years are striking your roof. Most of them will pass through it. Some of them will be absorbed. A few of them will scatter back into space. The walls of your room are, at this moment, being touched by light from galaxies that no longer exist in any form you would recognize. You are in contact, whether you know it or not, with the deep past of the universe. You have been, all along.
This, I think, is what the traveler learns in her long silence, if she learns anything at all. That the universe is not something you reach. It is something you are inside of. That the question of how far you can go is, in the end, the wrong question, because distance is not what the universe is made of. The universe is made of moments, and each moment contains everything the traveler has ever had access to. She, in her cabin, with her eyes closed, is no farther from the stars than she ever was, because the stars were never a place to be visited. They were a light to be met. I am aware that this sounds consoling in a way that might not, at first, be earned. Let me try to earn it. The real consolation is not that the universe is smaller than it seems. The universe is enormous. It is much more enormous than tonight's script has been able to describe. The real consolation is that the smallness of our lives inside it is not a failure. We were never asked to match the scale of the universe. We were never asked to travel its full extent, or to understand it fully, or to survive it. We were asked, if asked is even the word, to pay attention to the portion of it we found ourselves in, for the length of time we happen to have, with the senses and the minds we happen to be given. That is the whole assignment, nothing more. We will not reach the edge. We will not outrun the horizon. We will not witness the 100 trillionth year. That is not what we are for. What we are for, as far as anyone has been able to tell, is this: to be here, now, briefly, awake, and to notice. To notice the way the shadow falls on the wall, the way the kettle makes a small sound before it boils, the way a particular person, when they laugh, closes their eyes for half a second longer than other people do, the way a distant star, on a clear night, looks as if it is flickering, even though the flickering is only the trembling of our own atmosphere, not the star itself. The way grief, after a while, stops being sharp and becomes instead a kind of slow wait that teaches you something about what you once loved. These small things are not a consolation prize for not reaching the horizon. They are the thing the horizon was only ever pointing at. The horizon, all along, was a rumor of attention. The attention was always here. I did not expect this script to go this way when I started writing it. I thought it would be about distance. It turned out to be about presence. I suppose they were always the same subject, seen from two angles. There is one last thing before I let you sleep. At the beginning, I told you that the radius of the observable universe was 46.5 billion light years. I told you that most of it was already beyond our reach. I told you that the reachable portion was shrinking, that the door was closing, that the traveler could not catch the horizon no matter how long she ran. All of that is true. None of it has changed. But the observable universe is, and always has been, something we can observe. The light still arrives. The photons from 46 billion light years away. The photons from the cosmic microwave background. The photons from every galaxy still within our sight.
They come. They have been coming, uninterrupted, for the entire history of our species. They will keep coming for a while yet. Not forever, but for a while. Every night you have ever spent outside, under a sky dark enough to see anything at all, has been a night of receiving the universe at no cost. The universe has been arriving at the retina of every animal that has ever had eyes, without asking anything in return. The exchange, if it is one, has always been in our favor. We were never the travelers, I think. The light was. And tonight, wherever you are, whatever kind of day it was, whatever kind of day you have to face when this recording ends, the light is still arriving.
A little of it, right now, is passing through the room you're in. A little of it is being absorbed by the dust on your shelves, by the cover of the book you left open, by the back of your own hand if it is resting outside the blanket. You are being gently touched by things that were burning long before you were born. You are being gently touched by things that are no longer burning at all. I have, in past scripts, mentioned a single image, a light in a window, seen from very far away. I will not draw it tonight. You do not need it tonight. Tonight the light is not in the window. It is in the room with you. It has been, all along. The ship is still moving. The traveler is still traveling. The horizon is still retreating. The universe is still expanding, still cooling, still slowly letting go of the things that once filled it. If you are still awake as I say this, the last thing I want you to notice, and it is a small thing, but I think it matters, is how ordinary the room is around you. The walls are probably not especially interesting. The ceiling is probably a ceiling. There may be a clock somewhere, keeping a thin, small sound. There may be a window behind a curtain, a piece of furniture with something on it that you had meant to put away days ago, a cup or a book or a pair of glasses folded on a surface they should not be folded on. This is the world you live in. This is the world I live in. This is the world the traveler left when she climbed into the ship, before everything that came after. We have spent the last hour talking about the edge of the universe. We have spent it talking about billions of years, about the cosmic horizon, about the deep future. And yet the ordinary room is, in its own quiet way, the whole subject. The ordinary room is where the question was being asked. The ordinary room is where, if the answer is anywhere, the answer is. You do not need to go anywhere tonight. You do not need to cross galaxies. You do not need to survive the heat death of the cosmos.
You only need, for the next few minutes, to be here, in this room, with the particular weight of your own body on whatever surface is holding you, and with the particular soft sound of the air moving in whatever way it moves where you are. That is enough. That has always been enough. The traveler, at the end of her ship years, is still just doing that, still just in a room, still just watching. Her room is moving faster. Yours is not. That is the only real difference. And you are here. And the hour is late. And there is nothing you have to do. Good night.